Okay, in this example, we've got a car which is moving to the right. It's got a known speed of 80 meters per second. And at that point, the driver of the car decides to brake. Then as a result of a constant acceleration of the braking, the car is brought to rest after traveling an additional 60 meters along the road. What we're asked to find is what's the total braking force on the car during the braking. Okay, so let's start out with our usual first step. That is, look at the forces, draw the FBD of the car. We know the car is moving to the right. Friction force, therefore, is acting to the left. There's a resultant normal force there of N. There's a weight force of mg like that. So again, what we have here is friction, mg, and normal force N. I'm going to use x as being positive to the right and y as positive up. So when I use step 2, my Newton's second law, when I sum forces acting on this in x, friction is acting to the left, that's negative x, and we know by Newton that's equal to ma. Well, what we want to find is the relationship between friction and speed, change in speed. So we need to bring speed into it. By definition, A is equal to dv dt. Well, we're still not quite there because although we have speed in here, what we want to do is find the change in speed with position, not with time. So here we'll use the chain rule to change dv dt to dv dx dx dt. And since this car is traveling only in x along a straight line path, then dx dt is one and the same as speed, so this becomes mv dv dx. So now we're in a position to separate our variables. We'll bring the dx over in the same side with f. Right hand side we have mv dv. We integrate both sides from position 1 to position 2. 1 to 2. It says here that the friction force is a constant, so I can bring the F there on the outside. So left side becomes the integral of dx, so that's x2 minus x1. Right hand side, the integral of v dv, so that's 1/2 v squared. So I have 1/2 m v2 squared minus v1 squared. We're looking for the distance, the delta x, that it takes to bring the car to rest. v2 is a 0. So from this I can solve for friction force. The friction force is going to be equal to m v1 squared divided by 2 delta x. Delta x being x2 minus x1, that's the distance. So that's it. So the key part of this, actually, outside of setting up our equations with Newton's second law, is to recognize that what we need is speed as a function of position. To get it there, Newton basically gives us speed in terms of time. If we use the chain rule to change dv dt to v dv dx, then we have it in a form that we can integrate and bring in distance rather than time.